Kia ora, hello. Some of my students would like to know how I can find the sines, cosine and tangent of angles without using a calculator. You can only do that with 0, 30, 45, 60 and 90, or with any ease anyway. In the previous videos I've done 0, 45 and 90. So what I want to look at here are 30 and 60, and a good place to start is with an equilateral triangle. So draw one in with side length 2 units, whatever those units are, and then you know that each angle is 60 degrees. If you draw a line down the middle and then redo the side lengths to take account of the line, so the 2 at the bottom are 1, and then you can delete the old measurement, and you can also delete the right hand side of the diagram, and that's kind of useful because you then finish up with a 30, 60, 90 degree angle. We'll delete the ghost measurements, put in the right angle and the measurement for the new side, and the new side is going to be the square root of 3, because 2 squared is 4, has to be equal to 1 squared, which is 1, plus something squared, well, that will be square root of 3. And change the top angle from 60 degrees to 30 degrees because it's been halved with the action of slicing. So move the thing right to the top, and we can now, for the 60 degree angle, we can label the opposite, the adjacent and the hypotenuse. So there's the opposite, the 60 degree, adjacent the 60 degree, the hypotenuse. The sine of 60 is the opposite over the hypotenuse, which is going to be the square root of 3 divided by 2, and that's perfect. It can be approximated roughly as 0.8660, but only to 4 significant figures. The cosine of 30 is the adjacent over the hypotenuse, cosine of 60. Adjacent over the hypotenuse, that's going to be equal to 1 divided by 2, which is beautiful, and that makes a half. The tangent of 60 is opposite over adjacent, which is going to be the square root of 3 over 1, which is just the square root of 3, which is going to be around about 1.73205008, yada. But that's still just an approximation. Square root of 3 is perfect. Now we can change things. Looking at the 30 degree angle, relabel the opposite and the adjacent. The hypotenuse is still the same, so change those. Sine of 30 is opposite over hypotenuse, and so therefore for the 30 degree angle the opposite will be 1 and the hypotenuse will still be 2, so we get a half. Cosine of 30, the adjacent will be the square root of 3, the hypotenuse is 2, and we get, again, that's around about roughly 0.866, but that's just an approximation. Square root of 3 over 2 is perfect. Finally, tangent of 30, opposite over adjacent, which is the reciprocal of the square root of 3, and that's roughly 0.5774, but 1 over the square root of 3 is perfect. So to summarize, for 30 and 60, fractions, decimals, sine, cosine, tan, half, 0.5, root 3 over 2, which is that horrible thing, root 3 over 2 for the cosine of 30, again that same number. Sine is a half, and underneath my picture is 0.5. Tangent's going to be 1 over root 3, which is roughly that, and the tangent of 60 is going to be square root of 3, which is 1.732, and so on. For the whole cluster of angles, 0, 30, 45, 60, and 90, the results are, there we go, put them all in, and that is a nice little way to find your way through 5 angles, each with sine, cos, tan, 15 results that you can do without a calculator.